computer screen's got like your homework. It's got like the, okay, good. So here's the thing I wanted you guys to notice. Somebody just joined us. So here's the thing I wanted you guys to notice is that no matter what, there's a pattern, and it doesn't matter how big or small the triangle is. If it's a 45, 45, 90, right? No matter what, the legs, they're the length of the hypotenuse times the square root of 2 over 2, like no matter what. Like always and forever, amen. In fact, let me give you a couple examples. Just want to make sure that's like 100%, a hondo percent, like rock solid. So let me get my document camera started here. I wonder if this wonderful pink pen will work. Look at that. That's beautiful. And look at that. Isn't that horrible? I don't even know how I did that. Sad story. So look, here's what I want you guys to know. Like sometimes it'll say 45. It'll just like mark one of them as 45 degrees. So sometimes it'll say this, and that's how you know it's isosceles, okay? Sometimes it won't say 45 degrees there. Sometimes what they'll do is they'll mark it like this. And that tells you also that those two angles are the same. Excuse me. Sometimes it's a symbol like that. And that also tells you those two angles are the same. But there's another way to know that it's isosceles also, and that's if you know these two sides are the same. So maybe they'll tell you that both sides are like 6. Yeah? Or maybe instead of telling you that both sides are 6, what they'll do instead, they'll just mark both sides with like a little line like that. That also tells you that those are equal. And if they're equal, if these two sides are equal, then these two angles are equal. And if those two angles are equal and it's a right triangle, these have to add up to 90. So you have 2 times something that equals 90. So both of them have to be 45. Good to go? And then no matter what this is, these two sides are that thing times the square root of 2 over 2. Always and forever, amen, if it's an isosceles right triangle. So the moral of the story is that if you had something like this, and you knew those two sides were the same, and it said, what are they? And let's say you knew that this was 7. Nah, let's do an even number, so it'll reduce. Let's say you knew it was 6 times the square root of 3, and you were asked to find those. Do you guys know what they would be? Can you figure it out? Try it. You can either just like, when you get an answer, you can just like turn your microphone on and say, hey, I got it, or you can put it in the chat room. But try that. See if you can figure out what these two sides are. While you do that, I'm going to drink my wonderful coffee here. No school tomorrow. It's Good Friday. It's kind of weird. It's our last holiday. It's weird having days off, vacation days, when we're stuck at home. So anybody got those two yet? Or do you guys want me to do it and you guys can kind of see? Tell me what you like.
I would like to see better, just to make sure I got it.
Right, because
that's me.
So here's one of the problems, Alfredo, with yeah. So here's one of the problems. When you're learning at home, a lot of the time you read all the texts, you try the problems, you get the answers, you think you really understand, but it's only when you get some rude teacher like me that comes in and like pops your balloon and rains on your parade do you realize you didn't understand as well as you thought you did, right? But that's okay. That's why I wanted to have this session, because this topic of these two triangles is super, super important. You got to understand this super, super well. All right, so look, here's what we know. What if this is an isosceles right triangle, which it is, right? Whatever the sides are always going to be equal to the hypotenuse times the square root of 2 over 2. Always. That's a little blurry. It's not even any better. Oh well, it's going to have to be blurry. So no matter what, that's always the case. maybe I can make it a little better right here. If I zoom out, let's try it again. Man, ratchet document camera. All right, so whatever the hypotenuse is, right, the sides are that length times the square root of 2 over 2. So here, our hypotenuse, you see, is 6 root 3. So 6 times the square root of 3, and we have to multiply that times the square root of 2 over 2. Yeah? So this is over 1, right? That's over 1. So the 2, and this is a whole number of 2, like a rational, like a real, like a rational number. These are irrational, the square root of 3 and the square root of 2, but those can reduce to make 3, and then what you end up with is the square root of 3 times the square root of 2. You can multiply those together. So if this is 6 times the square root of 3, then those other two are 3 times the square root of 6. Now, let's see. I'm not real sure. That seems weird, right? So here's what I want to do. And don't get fooled into thinking there's like a pattern, like why these are switched. That's just a coincidence, I promise. But the Pythagorean theorem should hold true, right? So let's do that. Let's do that. Let's do that. Remember, these two sides are 3 root 6. So 3 root 6 squared plus 3 root 6 squared equals 6 root 3 squared. Let's see if that's true. Man. So be thinking, like, what's this? When I square 3 root 6, what do you get? Think about it for a second. I'll do it for you, but I want to give you a second to think, and I also want to give myself a second to have some coffee. That was supposed to be kind of funny, but it's also true. See, there's my wonderful coffee. Oh, man. All right. 3 root 6 times 3 root 6. Well, you can rearrange the order of things when you multiply, right? 3 times 3 is 9. The square root of 6 times the square root of 6. I would never usually write the square root of 36, but it is true. And the square root of 36 is 6. So this is 54. That's 54. Did you guys get that? Yes, no, maybe so. Oh, looks like we got a new person here. John's here. Hey, John, good morning. How you doing? Things going well? Let's see. So this is 54. This is the same, right? Try this one. You guys try it. 6 root 3 squared. Good. I'm glad to hear things are going well for you, John. So 6 root 3 squared. Well, you know how 6 squared is 36. The square root of 3 squared is 3. So that's going to be, I think, let's see, 36 times 3. That's 18. That's 108. And that's true. 54 plus 54 is 108. So it's true. It worked. Kind of ugly, I know, with those square roots. So let's try a simpler one. Let's say we had one like this. Okay. And let's say we knew that this was, I don't know, 14. Yeah. If we wanted to find those two, what we have to do is we have to take that hypotenuse, whatever it is, we have to multiply it by the square root of 2 over 2. So 14 times the square root of 2 over 2, well, that reduces to 7 root 2. So these are both 7 root 2. Do you see? Here's the thing you got to know. That's the most important part right there. So here, watch. We're gonna do this backwards. Here's what we got to know. For 45, 45, 90. Okay? The sides are equal to the hypotenuse times the square root of 2 over 2. Always and forever, amen. Always and forever, amen. So, like, for example, we can use that 2 ways. We can use that to, if we know the hypotenuse and we want to find the side, right? We could use it that way. Or if we know the side and we wanted to find the hypotenuse, we could use that either way. Like this right here, this is your PFG. That right there is your PFG. That's your formula, right? And so if we wanted to use it to find this one's really easy because it's already solved for the side. So the side is going to be equal to the hypotenuse times the square root of 2 over 2. That's for 45, 45, 90. So that's going to be 8 times the square root of 2 over 2. So that's 4 root 2. Boom, done. Yeah, whereas this way, this one, so here's what we know. We know the side is 6. The hypotenuse we don't know, times the square root of 2 over 2. So I'm going to put x here, like the variable x. So if we wanted to solve that, we just have to use inverse operations. And so here, let me make sure that it looks like don't write it like I just did, where it looks like the denominator 2's inside the radical symbol. It's not. It's like that. Okay, so if we want to solve that, you have to multiply by inverse. You have to multiply by the reciprocal. So you're going to have to multiply both sides by this. And so the square root of 2 reduces the square root of 2. 2 reduces with 2. X equals 12 over the square root of 2. But there's a thing with fractions. We want the denominator to be a rational number. The square root of 2 is irrational. So we have to do the thing called rationalize the denominator, where we multiply by this. This is equal to 1. When you multiply by 1, nothing changes. So it's going to be 12 times the square root of 2 over, well, the square root of 2 times the square root of 2 is the square root of 4, right? The square root of 4 is 2. So we can reduce that, and you're going to get 6 root 2 equals the hypotenuse. And we could check that. We could plug that in here, and then we could do the Pythagorean theorem. We could do all that kind of stuff. You're going to see that it works. So that's the first thing I wanted you guys to get. How are you guys doing with that? Talk to me, Goose. How are you guys doing with that? So far, so good? All right, that's good. How about Danny Boy? Davy Boy. I said Danny Boy. That's weird. That's weird. Hey, Davy Boy, how about you? How are you doing? Doing good. All right. And Alfredo, doing all right?
Yeah, doing fine.
Are you in pain?
I was stretching.
Oh, okay. All right. No problem. All right. So now, the other part of the special right triangles is the 30, 60, 90. Yeah? All right. So this one, a little more complicated, but not too bad. So here's a couple things you got to know. With the isosceles, the sides are the same, right? So here the sides are the same. Here the sides are not the same. Here's the thing. You see you have one side that's short, one side that's long, right? The short side, this side right here, is going to be opposite of the 30-degree angle. And the other one's going to be 60. So the longest side of a triangle is going to be opposite of the largest angle. So the largest angle here is 90. The longest side is the hypotenuse. It's opposite. The adjacent sides, remember, adjacent sides make the angle. So these two sides make this 30-degree angle. And this right here is the shortest side. It is opposite of the shortest angle. So yeah, that's how I knew, that's how I know that this is going to be the 30. So here's how it works. The short side, it's going to be the hypotenuse divided by 2. Always. So whatever the hypotenuse is, if it's a 30, 60, 90, right? It doesn't work for any triangle. And there are lots of triangles besides these two, but these are the two that we have to really understand and know, just like you know your multiplication tables, right? But the short side, so this side, whatever this side, will always be half of the hypotenuse for a 30, 60, 90 right triangle. Okay? Now, the long side, there's a couple ways you could say it. You could say, there's two ways we could do it. We could say it is the short side times the square root of 3. Or we could say that the long side is the hypotenuse times the square root of 3 over 2. Doesn't really matter. Usually we use this one, but they all work. Now, here's the deal. If you know it's a 30, 60, 90 right triangle, all you need is one side to figure out the other two. All you need is one side to figure out the other two. So if you know the hypotenuse, well, you can just plug that in here. You take half of it for this, and then you take the half multiplied by the square root of 3 to get this. So no matter what this value is, this is going to be half of it, and this is going to be that times the square root of 3. Do you see? So let's see an example. Let's say we knew that this was, let's say we knew the short side was 4, and let's say we knew this was 60, and that's a 90, right? If we wanted to solve this, well, we know that the short side is the hypotenuse divided by 2. So short side equals the hypotenuse over 2. So if we know the short side was 4, you could solve that. You would get 8. Yeah, you could probably do it in your head. Half of what is 4? 8, right? And then whatever the short side is, the long side is that times the square root of 3. Boom, done. And this still works because so the long side is also the hypotenuse times the square root of 3 over 2. So if you take 8 and you multiply it by the square root of 3 over 2, you can reduce that and you get 4 root 3. Do you see? So no matter what, that pattern always works for 30, 60, 90s. The other pattern is for 45, 45, 90s. One of the issues is dealing with these radicals, these square roots. That can be that can probably be one of the things that's the most tricky. So then here's the other thing. You were asked to find like the tangent of 30 degrees. And so people were asking questions. They were saying, well, for tangent of 30 degrees, am I going to use a calculator? And no, you're not. Not right now. Because you don't need it. Because tangent is, remember, tangent is opposite over adjacent, right? So this is the 30 degrees. That's opposite. This is adjacent. So that would be 4. Tangent of 30 degrees would be 4 over 4 root 3. Tangent of 30 is 4 over 4 root 3, right? And that reduces to 1 over the square root of 3. Now we have to simplify that. So you need to have that denominator be a rational number. So that's why you're going to multiply by root 3 over root 3. That gives you the square root of 3 over 3. Tangent of 30, square root of 3 over 3. Here's the other really big thing I want to show you, okay? Other big thing I want to show you is even if this was an 8, 4, and 4 root 3, tangent of 30 is the same, no matter how big or small the triangle is. So let's do one more. Let me show you. Now we're going to do the tangent of 30 again. So let's say we had this 30, 60, 90. And let's make this one ugly. Let's say this was 5 root 2. Oh, that's that's rude. That's rude. On a Thursday, while we're like in a virtual classroom. Oh, that's harsh. So what we want to do is we're ultimately, let's say we're going to be asked to find what's the tangent of 30 degrees, right? We know tangent is opposite over adjacent. So whatever this short side is, we have to divide that by the long side. Do you see? So tangent of 30 is going to be the short side divided by the long side. But we got to figure out what those are. And now here's the thing we know. I know that the short side is equal to the hypotenuse divided by 2. Yeah? So I know that the hypotenuse is 5 root 2 divided by 2. Those don't reduce because this is not 2. This is the square root of 2. This is what number times itself is 2. You see? So it's irrational. This is 2. We can't reduce that. But I now know that this is 5 square root 2 over 2. Okay? Now, the long side, let's do it this way. The long side, it's the hypotenuse times the square root of 3 over 2. Yeah? So the hypotenuse is 5 root 2 times the square root of 3 over 2. Well, that's going to be 5 root 6 over 2. Do you see that's the long side? It's going to be 5 root 6 over 2. You guys need to practice your square roots, huh? How many guys here? Tell me you can tell me in the chat, or excuse me, you can tell me in the chat, or you can just unmute your microphone. How many guys need to work on square roots? Like you messed those up or you forgot them? Yeah. Denitza's like, definitely. Who else? They're horrible.
I'm a little off on them.
Say it again. I'm sorry.
I'm also off on them.
All right. So I have a lot of stuff on square roots, like videos and things like that you can watch and practice. So I'll put those in Google Classroom for you, okay? All right. So now, tangent of 30. You're going to have to know square roots, by the way. And here, let me show you why. You have to know. Here, watch. Let's see. You guys can see that, right? One of the things in trig that we're going to be dealing with is this thing called the unit circle. And the unit circle shows you sine, cosine, and tangent of all of these. There's like a few basic angles that we have to know, like 30, 45, 60, 90, and then multiples, like 4 times 30 is 120, or 2 times 60 is 120, right? 3 times 45 is 135. 3 times 45 is 135. So like this first quadrant right here is kind of copied and repeated throughout the circle. But look at all these square roots. You've got to be really, really familiar with all of those. So that's why this lesson, even though it seemed kind of easy when you read it, it's a little tricky. And so we got to be like super rock solid with that. Yeah. So that's not a bad thing. We just got to learn it. We'll be all right. I have faith in you guys. We'll get there. Okay. So let's finish this one up. Make sure, let's finish this one up. So here's what we know. We know that the tangent of 30 degrees is opposite over adjacent. So that's going to be 5 times the square root of 2 divided by 2 divided by 5 times the square root of 6 divided by 2. Now, no matter what, I was saying that no matter what, this is going to reduce to this. Dang, it doesn't look like it's possible. But we can do this. Check this out. This is a compound fraction. See? This is the numerator. That's the denominator. So it's this divided by this. And the way you divide is, of course, you multiply by the reciprocal. So it's going to be 5 times the square root of 2 over 2, and then times the reciprocal. 2, 5 root 6. Are you starting to see? Do you see how the 2's reduce? The 5's reduce, and you're left with the square root of 2 over the square root of 6. That can be reduced to the square root of 1, right? The square root of 1 is 1 over the square root of 3. And when you rationalize the denominator, you get the square root of 3 over 3. So here's the thing. 1 over the square root of 3 is equal to the square root of 3 over 3, and that's equal to the tangent of 30 degrees. This right here. This is true. This is true. And we'll show you on the calculator. All right. So, all right. Let's clear all that. So 1 divided by the square root of 3. Boy, 0.577. All right. Square root of 3 divided by 3. Whoa. Dang. Tangent of 30 degrees. Whoa. Dang. Mic drop. So no matter how big or small the triangle is, no matter what numbers it is, if it's a 30, 60, 90, the tangent of 30 is always the same. Tangent of 60 is always the same. Tangent of, even if you did the sine of 22 degrees, it doesn't matter how big or small that right triangle is. It wouldn't matter. If this is 22 degrees, the ratio is going to be of the hypotenuse over the opposite, or sorry, opposite over hypotenuse. No matter how big or small that triangle is, no matter how big or small, the sine of 22 degrees is always the same exact number. And that's one of the, so that's like the payoff. That's why trig is so powerful is because, and it's still like used like massively today. If you want to measure something indirectly, you use trigonometry. Like you see people, maybe you've seen people like doing construction or like building a road, and they have this like, they have these devices that measure things optically, and what they do is they measure the distance in the horizontal side, and they actually make a right triangle, and they use sine, cosine, or tangent to figure out what it is they can't measure directly. It's used like massively all over the place all the time, even though it's super old. It's way older than algebra. So anyway, how you guys doing with all that? I know that it's a lot of information. It seems like super simple, but yeah. So try that homework. If you already did it, see if you can revisit it. See if you can try that homework again. It's not going to be due till Monday. I gave you 2 days to do this. That's why I broke the unit up into 2 parts. So if you haven't read both of those parts, you really need to. So read both parts, and then try the homework. Watch the video. Review this one again if you get stuck. And then, as always, if you guys have questions, just send me an email, okay? I hope you guys are having a good day. You're welcome, John. No problem. Absolutely. So I hope you guys are having a good day. If you need anything at all, I don't know that I can help you, but maybe I can find somebody who can help you. Lots of people are helping lots of people right now. So if you're in need of anything, just pipe up. And can't wait till we get back to class again. I'm looking forward to next year. We have a real challenge on our hands, but I like challenges. They make me tick. They make me happy. I like having a challenge. So our challenge is that this is tough. And what we're learning is really difficult, but we'll be all right. We'll get through it. So anyway, I'm going to go ahead and end this right now. And I hope you guys have a wonderful day. Just reach out through email, Google Classroom, whatever. Let me know if you guys have questions, okay? So I'll talk to you later.